we're going to use this surveyor and these small instruments, the analyzing rod, the wax trimmer, the cardboard marker, the undercut gauges. We will begin using them to do the surveying of a cast. This is now, we're talking about the initial survey, which we do on our primary casts. We fix the cast. We need to make sure it's stable by securing the screw. We need to make sure that the table is totally zero. This type of surveyor has like a point where it clicks into location, so you could easily identify when it's on zero tilt. We're going to fix this location of the table, and we will begin adding our instruments sequentially. So now we're going to do the initial survey. The first instrument we will be using is the analyzing rod. It is a metal rod with parallel sides. So if any location, at any location, this will be representing the path by which the RPD will be going in and out. So once the patient wants, for example, to remove the denture, the removable partial denture for his cleaning, he can take it out in this direction. So if I want to describe now the abutment teeth. Abutment teeth are the teeth located close to the edentulous areas. This edentulous area is bounded by two abutments. This edentulous area is bounded by one abutment. And these are called abutments because they will be holding some components for support and retention of the removable partial denture. If I just take a quick look at these abutment teeth, I could not correctly describe the areas of undercuts. While if I use this analyzing rod and just putting it close to the tooth, in the path of insertion I had chosen, just locating it close to the tooth, now I could see where the undercut is present. I could visualize it better. I also could put it here on the side. Just putting this analyzing rod close to the tooth, I have now a reference to compare the tooth surface to. And now I could easily see the undercut. It is the area located beneath the point of contact of the analyzing rod with the tooth. I could see now that the tooth has multiple undercuts. If you could see on this side, we have an undercut here, which is this space beneath the contact area. So we have multiple contacts and undercuts. If we can see here, we also have another undercut, another undercut, another undercut. Now, visualizing the cast using this reference tool, I could say that I have multiple areas candidate for looking for undercuts and gauging undercuts in. I could also try to equalize undercuts by tilting the cast. This is a step we will do later on. To keep it simple, we're not going to tilt the cast. We are going to utilize the same undercuts that we have here. Some of the undercuts we will utilize by the components. For example, these possible undercuts. We will try to utilize and choose from them which one that I would like to use for retention. This also buccal undercut is also utilized for retention. While this proximal undercut, it will be blocked out for the protection of this marginal gingiva. Now you can see that the marginal gingiva is covered by yellow, and the tooth surface above it should also be covered 1 to 2 millimeters above, and this area will be blocked out. So some of the undercuts will be utilized, some of the undercuts will be blocked out and not utilized on it by intention. There might be also sometimes some tissue undercuts. If I look at this side will be holding some of the components of the metal on here, but later on we will add a creel extending up to here. If there is an undercut that I might not need to engage, I could first visualize it by the analyzing rod. So it's also utilized for tissue undercuts. For example, here, we have a tissue undercut. Can you see the space beneath the contact? So if I'm going to extend one of the metal clasps, I need to block out this undercut. So this soft tissue undercut beneath the metal framework should be blocked out. This is the reason why we add a blockout material here. So now, using the analyzing rod, I have identified areas of undercuts I want to utilize and areas of undercut I want to block out, because the metal framework and the metal design will be crossing over them. So that was the analyzing rod, the analysis of the areas of the cast in reference to a vertical path of insertion. Now, to identify these undercuts better, why not draw a line on the bulges of the tooth to make sure that I could further see them? So we fix here the marker protected by the sheath, because sometimes if I'm pressing on this, it might break because carbon markers are weak. We need this metal sheath to enforce it. Notice that when I fixed this instrument to this spindle, it also has the same features that we noticed in the analyzing rod. It is parallel to the path of insertion, meaning that at any location, this line is parallel to this line, parallel to this line, parallel to this line. And the path of insertion we have chosen was vertical in relation to the ground. If I go and run with my marker around this tooth, I would find there's a line that has been drawn automatically. This line is the maximum bulge of the tooth. Now I could see it and specifically identify it on the tooth. Notice the way I'm drawing. The carbon marker should be touching the maximum bulge of the tooth. The lower part of the marker should be beyond the maximum bulge of the tooth, close to the margin of the gingiva. Other than that, if I don't use this location, what will happen is, at any location I'll be drawing, because there is no reference for me, and the marker is not beyond the bulge. So I want to make sure that the marker is beyond the bulge for it to draw the bulge correctly. So I have 2 points of contact. You can see that I'm on this bulge and close running around the margin of gingiva. Here, I could also see my maximum bulge of the tooth. And here, I could also, on the palatal side, see the maximum bulge of the tooth. Once more, notice that I'm almost touching the margin and gingiva, leaving the marker to draw by itself when it crosses over and the maximum contour of the tooth. So what are the components that will be around this abutment? We have a plate or a bracing arm or reciprocal arm. The location of this component of the RPD should be exactly on the bulge of the tooth. Here, we should design our guide plane. Having this line drawn on this proximal side of the tooth shows me that there is a bulge, and this should be removed by intraoral preparation. While on this side, we have the undercut we will be utilizing for the retentive arm of the clasp. I draw the same lines on the other two abutments of the bounded area. So, looking closely at it, I could draw with my marker all around the tooth. I'm running with the marker close to the marginal gingiva, letting it automatically cross over the maximum bulges of the tooth, and going even to the palatal side of the tooth, abutment tooth. And now you can visualize the point that I said in the beginning, where the maximum bulge of the tooth is not fixed. It runs in different locations depending on the surface of the tooth. This is our last abutment. Once more, close, rotating. I rotate the marker, avoiding the sheath touching the tooth. I want the marker touching. And I go around the abutment tooth all around. Once more, notice the morphology of my survey line. Now, having this line drawn, I could confidently say the area beneath this line is the undercut area. The line itself is the maximum bulge of the tooth, and the area above it will be not utilized by any metal component. Now I need to measure undercuts. Let's go back quickly to see our removable partial denture. And remember that we need, for example, to add retentive arms to do the retention. They might be clasps in the shape of a clasp or an eye-bar. The end of these structures should be ending in the undercut. So I need to measure the undercut suitable for this material. We're going to use chrome cobalt material. So let's take a bit simpler model showing an object that is oblique and round. In a way, a simpler demonstration of the tooth. I would find that we have what we call the maximum bulge. This is similar to natural tooth morphology, where some of their locations on the tooth, we will have a maximum bulge. If we look at it vertically, we will find that there are areas hidden from this vertical path. This is what we call undercuts, hidden inside. And I need to make sure where is the maximum bulge, because by vision alone, I would not be able to decide where it is. I need an instrument to draw this. And also, once I got the survey line, which is on the maximum bulge of the tooth, I need to know which undercut depth should I use. So the idea is, I would use the analyzing rod first to locate the maximum bulge. So utilizing the carbon marker parallel to the path of insertion that I would like the denture to go in by, if we draw on the bulge, we will find that a line is now present. This is what we call the survey line. The amount of undercut utilized in a tooth is dependent on the material we're going to use. Suppose this instrument is a stainless steel wire, and suppose this instrument end is a chrome cobalt. This chrome cobalt is more rigid from the stainless steel wire you have used in your RPD when wire bending. That means the amount of undercut I should use for this one is less than the undercut I use for the stainless steel wire. So at what measurement should I use? I need to gauge the undercut. So this is the philosophy behind having a vertical component of the undercut gauge and a horizontal component of the undercut gauge. So to make sure I'm measuring this correctly, I should have 2 points of contact. One here on the vertical and one here on the horizontal. If I'm looking at this undercut, the vertical is not touching, so this is incorrect. If I'm looking down at this undercut, the horizontal component is not touching the tooth, so this is also incorrect. They should have 2 simultaneous contacts on the tooth at the same time to make sure that this undercut is measured correctly. We will now redo it on the tooth on the cast. We have to have 2 points of contact to measure a correct undercut. The vertical rod and the undercut gauge should be touching the tooth simultaneously to say this is an undercut. So suppose I'm doing like this, only the undercut gauge is touching, that's incorrect. If I'm doing like this, for example, this is not touching while this is touching, it's also incorrect. I need both of them to be touching. So I'm going to begin here. Begin going down, trying to touch both points. But I find that I'm contacting the gingiva and still the vertical rod is not touching. If I rotate here, I would find, yes, I have a contact, but this area of undercut is very close to the gingiva. And now if I go around, I find at this point I have two contacts on the vertical rod and on the undercut gauge, so I could confidently draw a point and say this is a suitable undercut for chrome cobalt. I might need another area or another undercut for another reason. This is also another area that has a suitable undercut. The suitable undercut should be away from the marginal gingiva. So remember when we found the undercut very close to the gingiva, we did not choose it? Still rotate the abutment tooth, I could also find another point with a suitable undercut. And it's present over here. So, surveying this tooth, I find I have 3 points I could utilize for retention. Going to this abutment, from all of this yellow area of undercut, I'm trying to find my suitable location. I could see that I have a suitable undercut here. I go around and I have another suitable undercut around here. I have another undercut here. And I could also have another undercut on this side. This tooth has multiple areas of suitable undercut. But because in bounded saddle areas we usually use a clasp, that means we might use this undercut closer to the proximal surface. Going back to the zero tilt, I'm going to try to find undercuts here. You can see I'm trying to find a point where 2 points do contact, and I have an undercut suitable here. I have a suitable undercut here, and I have a suitable undercut here. Okay, this undercut is suitable, but very close to the gingiva, I will exclude it. So, this abutment has multiple points of suitable undercuts. Once more, our basic design will be a clasp, so I might utilize this or this, but this is closer to the embrasure and more compatible with the tissue. The clasps, I would like the technician to do for my design. So, if we look at this design, we see that for the bounded saddle distally, we're going to do a clasp. Where should a clasp run? The clasp comes from the guide plane and should be running over the survey line. So the bulge of the clasp should be running over the survey line. Notice that I'm still over the survey line. And the last tip, or the last third of the clasp, goes into the undercut. So this is my clasp. And the tip of it is inside the undercut. For this side, I might choose the clasp similar to this. But notice this is an aesthetic area. The patient would like to hide the metal as much as possible. So if I extend the clasp like this, metal will be showing while the patient is talking. So for an aesthetic reason, I'm going to change my design from a C shape. I will do it here like an I bar. An I bar, minimal amount of metal will be showing through. So I want to draw for the technician my I bar. The I bar originates from the saddle area, from the metal of the mesh in the saddle area. It rotates. The I bar should have a horizontal arm approaching the tooth. I could end my arm here, here, or even here, because I have multiple points of undercut. I will utilize the slightly mesial undercut with the middle undercut. Okay, and we know that the metal should come in round angles, so we're not going to do a sharp angle here. And it goes down away from the marginal gingiva, preserving the oral health of the tissue. And crossing over this undercut. Okay, and extending vertically 2 to 3 millimeters above the gingiva. So I'm utilizing the undercut that is suitable. If this undercut was on the marginal gingiva, I would not have utilized it. I might go to use another one. So now this is the eye bar. On the other side, I also have an aesthetic reason, and I also have a biomechanical reason, where this is a free-end saddle. The free-end saddle, if I engage the abutment using a C-clasp, it will be too much engaged in the forces. There is no other abutment. So that when the patient is biting on food, the RPD will tend to rock on this side. So not to traumatize the tooth with this extra load from this huge free-end saddle area, we usually prefer also an eye bar. It will reduce the engagement. So I'm going to utilize this undercut, where I'm going to end my eye bar. I'm going to run vertically in the first 5 millimeters below the marginal gingiva, and then rotate, allowing a self-cleansing area, an arch shape, and blend with the mesh area without any sharp angles. This will be the clasp. So as you see, I'm trying to draw my metal framework on the cast itself, and this is called an initial design. The other components that I'm going to draw, I am going to place a mesial rest here. I'll place a rest inside here. And I'm going to do a guide plane in this area. And then the metal will go down, and over this free-end saddle area, it will be a mesh shape. And during drawing the design, I could also instruct the technician to do a stopper, so I could define an area for the stopper. The stopper is part of the metal. For these, we're going to do a guide plane here. On the proximal surface here. Going to do a guide plane here. We're also going to add a mesh. You don't need a stopper because we have good support for the RPD here coming from the rests. So we're going to draw the rests, and we'll have a rest here. Now, each clasp should have a component that prevents the tooth from moving during the crossing over the bulge. Here, this rest will act as a reciprocation for this clasp. This clasp needs another bracing arm or reciprocal arm. How do I draw it? Reciprocal arms are located over the maximum bulge of the tooth, opposite to the clasp. So this reciprocal arm will be drawn over the bulge. Here, this rest will be extending into a plate, so it will be attached to a plate. This clasp will be attached, will be opposed by another plate. The plate will be extending to over the maximum bulge of the tooth. And now we could draw the outline of our major connector. Major connectors run over the palate away from the marginal gingiva of the teeth and inside the grooves. The denture usually should end inside the rugy area. The rugy area is the rough area of your hard palate anteriorly. So this rugy area, if I end the metal over it, it will be irritating for the patient. So I run in the valleys between the eroge area. Posteriorly, the last abutment is the distal extension of the RPD, and I run in a I run down in an oblique motion, but once I cross the palate, I should be straight, because the tongue will be irritated by any line crossing the palate, not perpendicular to the suture area. Then I complete my curvature. The metal will be ending to support the acryl up to the last bit, and then it runs connecting to the mesh. The mesh, as you see, does not extend over the tuberosity. Now this is what we call an initial design for the cast. For our RPD, utilizing the features that are already present in teeth, remnant teeth in the arch. As a student, you will be also utilizing your surveyor to train yourself on how to do guide planes. This is what we said is a guide plane. It's the flat surface we prepared on the teeth to allow the RPD to go in and out into location in a single path of insertion. We said that the natural teeth come with normal contours that are bulging, smooth, and continuous convex surfaces with some concavity later on. So to make this area flat, which is the guide plane area, we need to trim the tooth inside the patient's mouth. But as students, you need to train yourself on how to hold your instruments and control yourself, and try to put in notes on how much tooth structure I need to take away before trimming, before reaching to a parallel guide plane. So I put my cast on the surveyor table at 0 tilt. I mount on my instrument, which is now the wax trimmer, and I begin scratching my cast, because if you look closely, there is a bulge here. I don't want a bulge, I want a flat surface. In my design, I've drawn that this surface should be a guide plane. So guide planes should be flat to engage the tooth in a safe way. So I use my wax trimmer to train myself on the carving of the tooth structure until I got this flat surface. This flat surface should extend vertically 1 to 3 millimeters. It should rotate slightly around the tooth. Okay, and it is parallel to the path of insertion. Now I'm confident that this surface of the tooth, now that I've decided to be the guide plane, is now flat. I could put a note on my form that for this area to be flat, I need, for example, only 0.5 millimeter reduction of enamel. I didn't need a lot. Maybe on other teeth you have more bulge. So I need to train myself. How am I going to hold the burr? The same direction by which the trimmer is going down the tooth, this will be the direction that I have to put my dental burr when inside the clinic I'm trimming the teeth. This is the same direction I'm going to hold it. So the training you get from using the surveyor will make your eye familiar with the angulation which you should choose with your hand while trimming the tooth. I should not trim the tooth in this direction. The burr should be exactly in the same direction. I hold the burr and fix my tooth finger rest and try to trim the tooth in the same direction I am using here in the surveyor. So once more, I could notice how much reduction there will be. The tilt I've chosen is 0 tilt. I have equal amounts of reduction, also 0.5 millimeter here. In my trimming, I do not touch the last 2 millimeters of the tooth where it should be protecting. I should be protecting the marginal gingiva. So the guide plane does not extend to the lower part of the tooth, only the first 2/3 of the tooth. Okay, so this area that you see beneath here is empty. No guide plane is present here. Let me take away the stained material so you see this empty space protecting the marginal gingiva here. Still on the same tilt. I'm going to train myself to do this. So I'm training myself that inside the patient mouth, if I'm going to choose this tilt for this tooth, I'm going to preserve it when I'm trimming this tooth, and also going to cross over to the other side with the same tilt. So I train myself, and I find that also this tooth needs amount of reduction, similar to that of the other side. And once more, notice the empty area here beneath the guide plane, 2 to 3 millimeters protected. After finalizing my initial design, I need to take this cast out. But for any reason, during the process of taking approvals, discussing with the patient might not approve some components, or the doctor would tell you, please repeat the surveying for looking for a more suitable undercut or for another reason. So taking this cast out and putting it back in would propose a problem if you had a tilt. If it was a zero tilt, simply you can put a note that this survey was done on zero tilt, and you take the cast out and you put it back on the same tilt. Okay, it's zero tilt. But suppose I had a tilt added to here. I need to put the cast exactly back to the point that I took it out from. We do a process to do this called tripoding. What is tripoding? It's trying to place 3 markers on the cast by which I could reorient my cast when I put it back. For this purpose, I use my carbon marker. I could use the tripod lines or dots. Let me explain the dots first. Dots are placed preserving. I try to find a vertical position for the marker where it touches 3 parts on the cast that are not utilized inside the design. So I draw my design here. I try to find 3 points away from my design that they contact simultaneously together. So for tripoding, I need to fix the position of my pencil, marker, carbon marker. I try to find a tilt. Yes, I would say now it's fixed. The marker no longer goes back and up and down. And I could choose a soft tissue area where it touches. So you can say that this dot is drawn here, and I could place a circle around it. This is the first point of contact. I'm trying to find another, so I find one here. If you can rotate it. Okay. Just to let you see, I placed on the same vertical position now. It's vertical and horizontally fixed. I have a point here. So I could put a dot and circle it. And I have a point here. I could put a dot and circle it. I could place a fourth one, just as an extra. I could put a dot and circle it. Now, what happens if I take out the cast? At any tilt, if I want to put it back, this cast would not have these 4 points contacting together at the same time unless it's at the same tilt I began with. So suppose I'm choosing this tilt. I have by default, I put it like this. See, this point can be in contact, but this one is not, it's away. It will not go back to the having all 3 dots touching at the same time unless it's on the exact tilt I took it out by. The last tilt I took it out from. So this is the first method. The second method of tripoding, well, it might be easier to draw lines on the cast. So we draw lines, once more using the carbon marker. We make it free. These are tripod lines. and we let it go on the side of the cast, and we draw a line just parallel. I could draw a second line here, so I choose 2 posterior dots and 1 anterior as a reference. This is the second line, and this is the third line. And then now I can take the cast out. If I place the cast back at any tilt other than what I drawn the lines at, I might have one line parallel, but the second line will not be parallel. It will be tilting. These lines will not coincide with each other unless I put back the cast exactly in the same location I began with, and now they are parallel with each other. Okay, as you can see. So, 2 posterior and 1 anterior reference point. And now I'll dive back. This is called tripoding.